We did this problem yesterday. So if I have a function, f of xy, and in this case it was x squared minus 2xy plus 2y on an interval, a domain, xy. And for the most part for this class, your domains are going to be rectangles. So there's my domain. What I mean by rectangle means that I can plot the rug on the floor. The x is between 0 to 3. So what it's going to look like is I'm going to have this region right here. And by the way, get used to drawing these regions in the xy plane before you do it, because you're about to head to double and triple integrals. And if you don't draw the region, you're going to be suffering a world of hurt. Trust me, as someone who went through this. So x is 0 to 3. Here's 3, 1, 2. If you're not taking notes, I'm going to assume that you can go to the front and explain all this, and I'm going to sit down and sit back. I want you to have a record. Pull out your stuff. Take notes. So if I draw this region, it's going to look like this. Like that. So what you have is a rug on the floor. Those are the dimensions of the rug that's on the floor. And then you have this surface on top of it. Think of it as there's a rug on the floor, and then the roof of your house has some kind of weird wiggle because something damaged it. So it's got a surface. And then you'd like to know where the maxes and mins of this ceiling is that's got a surface on it over just that rug. I don't need to classify. You actually don't need the second derivative test here. I almost wrote that down. You don't need it. Do you remember the steps when you did this in one dimension? The first step was to find the critical points, take the derivative, set it equal to 0. Actually, when I gave students a function after a while, they would just take the derivative and set it equal to 0, even if I didn't ask them to. It's like autopilot after a while. So you do as before. Find the local maxes and mins by taking the derivative. We did the same one yesterday, so I'm going to breeze through these steps. Even I think someone in here took a picture of the checklist I gave at the end, but the actual steps of what I did was not recorded yesterday. So quick and dirty, you take the first derivative, fx is equal to 2x minus 2y, and that's 0. Fy is minus 3x. Is this supposed to be 3? This is supposed to be 3, sorry. Otherwise, it's not interesting. Plus 2, and that's equal to 0. Does this right here? Correct? Yeah. I had a 3 there. I wrote it as a 2 right at the top here. It's supposed to be 3. Yes. I can make it 2 and redo the problem, but it's not interesting. All right, so we did this yesterday. You're simultaneously solving both of these equations at the same time. So you've always, typically the way these problems are set up they're set up like one of them's easy to solve and the other one's not. So the easy one is number 2, and it's usually that way. It's number 2 because it's a cooked up problem. It's not a real problem. Since 2 is easy, you solve for x. So you get x is equal to minus 2 over minus 3, which implies x is 2/3. And then since you solved it, you substitute it back into the first equation. Sub into 1, and that gives me 2 instead of x, I'm going to take 4/3. Who made up these fractions? I want it really easy. I wanted the answer to be 1. I think it was 2. We did the same one yesterday, didn't we? Yeah, I want it to be 1. Sorry for those of you who don't have erasers.
I think you just copied the 2/3 into the 4/3, like when you subbed it.
I think this is supposed to be, I can't read my own handwriting. Yes, it's minus 2x. I know what I'm doing. It was a 2x, yes. Because I made it up so it's easy. Like, what did I do? Did I make up fractions on purpose?
Let's change the domain at all then?
No, the domain has nothing to do with it yet. So we get minus 2x plus 2. And now I get my x is equal to 1, sub 1 into that, and I get exactly what I wanted to get. So your critical point is 1, 1. What made me doubt what I was doing was I wouldn't make up a problem that had 2/3 of the kind of thing. Like, that would be not a cool thing to make up. Okay. The next thing is you do a little check. I'm going to put this as step 2. Step 2, check that that value is inside your domain. Is it in the domain? 1, 1 is right here. It's in the shaded region. That belongs to. So 1, 1's an element of that set D. So you have to check that. If it's not in D, you don't have to worry about it, but you do have to check this. So I'll wait till everybody's caught up writing, and I'll go to the next.
And in what scenario would the critical point not be?
Well, you can think of you have a rolling thing, right? And maybe it's like part of the saddle, but the parts of the saddle that actually have it's like the rising part of the shadow. So it could be something like that. In fact, 103, you have examples where they're not going to have any critical points at all. So the critical point could be outside that region. Your mountain could be outside the region. Your bowl could be outside the region. And inside the region it's only increasing or decreasing or doing something that doesn't have any plateaus. So, okay, step 2. I did it already, but I'm just going to write it down here. Step 2, check that CP, and I put CPs, there could be more than one, are in domain. Now, if I want to be a jerk and write a test, if I was really mad at my students and I wanted to write a test, not that saying that I have done this, but I would give them a problem that had one critical point was inside the domain and one was not. And I make it so that there's 2 critical points that came out. And then I'd really mess with them because I have lots of points to go and take off if they messed up. I wouldn't do that. I'm just saying that if I wanted hypothetically to be mean. But you see, like, what that would be a problem, right? If they don't do this step, then they're going to have 2 critical points, and they're going to do all the, like, is it a max, is it a min, and it has nothing to do with the problem. One of them does, and one of them doesn't. So that's a way to mess with someone. I guess those students are right. Like that said, math teachers just find evil ways to hurt students. Which is one of the things. Okay, step 3. Examine f of xy on boundary of D. The notation for boundary is, again, that partial symbol. It's boundary of D. That's what the notation means. So I do have to have that region drawn. I'm just going to redraw it instead of go back. This is 0, 0. I'm just going to label the corner points. 3, 0, 3, 2, and 0, 2. Along this piece right here, x is always 0, and y is just going to be y, and y is going to run between 0 and 2. Along the bottom region, down here, the y is always 0, and the x is running from 0 to 3. Along this region, the x is always 3, and the y is running between 0 to 2. And at the top, x is always 0. X is running, and y is always 2. So I just label up my figure.
So step 3 is the same method.
On the boundary. So you actually remember that you on the count one problems that you had like the interval and you don't remember it. I remember because it was like around the pressure, like all of a sudden it just got confusing. But you're examining f of xy on the boundary of D, and this is the notation for boundary. So you might see it as that notation. And I'm going to mark these. I'm going to call this L4, line 4 over here. I'm going to call this one line 1, and I'm going to call this one over here line 2. I just want to stay with whatever I'm writing in my notes. And the top one here, I'm going to call that line 3. So along line 1, x is free and y is always 0. So f of xy, which was forgotten already.
X squared minus 2xy.
Yes. So along this line, x is y is 0, so the y's drop out, and I just get x squared. What's the maximum value of x squared along when from x goes to 0 to 3? What's the largest value you're going to get from 0 to 3? X squared. So if I plug in numbers for x, 0, 1, 2, 3, where is it going to be the largest? All right. Max at x equals 3, min at x equals 0. Box that away. All right. I'm tired. You guys go out and do L2, L3, and L4. Find me where the maxes and mins along that line is going to be. First of all, do you get what I did here?
Where do you get that x squared from?
Along this line, y is 0. So I go back to the original function, I stick y equals 0. So maybe I should put.
Is this still step 3 or is this like step 4?
It's a step 3. It's like it's the same work, copy and paste. And just so I make sure you understand it, what would I do here? What would I plug in on this line? 3 for what? 3 for y, or for x, and then y would be just y. Because y would range from 0 to, y would go from 0 to 2. So the extent of the y would be 0 to 2. Go for it. Go find the maxes on L2, L3, and L4. Go back to the end.